I'm Anil Kumar. Welcome to my series on matter. We'll discuss what is matter, what is not matter. We'll have a reference to particle theory of matter. We'll talk about states of matter, characteristics of matter. We'll also discuss how density, mass, and volume are related. And a very important question here is, how are photons and plasma related to matter? Well, any queries in this regard, you can send me an email on the given address. Now here, there are a few things which I really want to mention. As far as the characteristics of matter is concerned, we'll touch upon physical and chemical properties. Right? As far as density, mass, and volume relation is concerned, you need to look into examples. Perfect. And also, as far as the particle theory is concerned, you have to look into another video, right? So for all these three topics, we have additional information. In the form of videos. So you can look into those videos. Perfect. So let's begin with our talk on what is matter. So when I say what is matter, then matter is any substance that has mass and occupies space. So there are two things very critical: mass and it occupies space. So these are two things. So what is matter? So matter has two things, which is mass and volume. So when we say space, that means volume. Correct? Now in particle theory, which we'll just soon touch upon, we know there are particles, right? So matter is basically made up of indivisible particles which have mass and occupies space. So that is one way of looking into matter. The other way of looking into matter is anything which we can see and touch or feel is matter. Right, so that is what is matter, right? I shouldn't really use the word feel. We'll restrict ourselves to see and touch. Is matter, right? So everything which you see here, paper, pencil, oranges in the market, whatever you see, everything is made up of matter, right? So that is base of matter. Perfect. Now when we say it is made up of indivisible particles, it means what? It means that cannot be divided further, right? So let me write down indivisible particles. So these are the smallest particles known to us that cannot be divided further. So in our discussion, we'll just keep it as particle in general. At times, we may use the word atoms. Right? So we might use the word atoms. So atoms are those indivisible particles which cannot be divided further, right? So that is kind of clear, okay? So in two ways we can look into matter, that anything which has mass and that occupies space is matter. So now our important question is, what is not matter? So let's give an example of not matter. Right? So what is the example of not matter? The example of not matter is energy. We normally refer to this as photon. They have no mass. And therefore, they are not matters. Is that clear to you? Right. So with that, I think we get good information about matter. So anything which we can touch, we can see, is matter. They are made up of particles. They occupy space and volume. Correct? Next, we'll now refer to particle theory. So on particle theory, we have another video, right? So I'll provide you a link for another video. However, since we have said that matter is made up of particles, right? We know particles are the smallest known substances to exist and cannot be broken. Particles have mass. They occupy space. Now when you look into these things, that is, one, we are saying matter is made up of particles, and particles are smallest known substances to exist and cannot be broken. Then we say particles have mass and they occupy space. So that is what particle is. Now in particle theory, we learn about its characteristics. So now to understand matter better, since it is made up of particles, we take help of particle theory. That describes the behavior and characteristics of matter. Correct? Now in details, how and what is particle theory? Those 6 points we'll cover in particle theory. So there are 6 key points which we'll discuss in the video. So link is being provided. You can look into that link and then it'll be absolutely clear to you. Perfect. So that is a slide from the particle theory. So these are the 6 points. Matter is made up of tiny particles. All particles are in constant motion. All particles of one substance are identical. Particles are attracted to each other. Temperature affects the speed at which particles move. Particles are close together in liquids and solids. Gas particles move quickly and have large space between them. Perfect. So we'll discuss all this in our video. Now when we talk about matter, we say matter has three states, right? So the states of matter basically are three. So there are three different states of matter. Let me list them here. We say solid, liquid, and gas. So these are the three states of matter. Now exactly how are they different? Is basically we know matter is made up of particles, right? So here particles are compact, can't move freely, right? Now in this case of liquids, the particles can slide. So they can flow, right? But still they are close together. In case of gases, the particles are free to move around, right? So I mean to say, as far as the force of attraction, because every particle attracts the other particle, is very minimal, right? So the particles are free to move around. Now because of these properties, what we see that the solids are compact, that means they are more dense, and gas is very less dense. Now what is density? We'll discuss this. It is the mass in a particular volume, right? So which is mass in volume, right? It's ratio. So we'll talk about density soon in this particular video. But important thing here is, in a container, if I place a solid, in that case solid has its own shape. So it retains shape, is not changed. In the case of liquid, it takes shape of the container. And as far as gas is concerned, it occupies the container. So it does not have a defined shape, right? So it occupies everything, the space in between, right? Now it is important to see that we're talking about particles when we talk about matter. So in solids, the matter particles are kind of close together. Here they are close, but they can flow. But here they are very, very far apart, right? So that is how. So solids, they are more compact. The force of attraction between the particles themselves is so strong that they don't let it move. So it's kind of stationary, right? In this case, it can slide. So that is kind of important thing. And here it really moves all around, right? So these are the three states of matter. Now, it is important to understand that any given substance, can exist in all three states, right? So a very good example is ice, water, and vapor, right? So good example is ice, which is solid, water, and vapor. So in all three states, it is kind of the same substance we're talking about. Ice is the solid form, water is the liquid form, and vapor is the gaseous form. And the thing which brings change into these things is temperature. So the key word here is temperature. So when you go through the video on properties of particles, you will understand temperature brings about this change because as far as the temperature is concerned, if you increase the temperature, particle movement increases, right? So increased temperature, movement of particle increases. So that brings about this change. So if you have ice, it cannot really flow, but when you heat it up, then the particle movement increases, it can slide, and if you further heat, it boils and changes the state to vapors. The reverse is also possible, correct? So the reverse is also possible, and since it can be both ways, it is a physical change. We'll talk about it soon. See how everything is related, correct? So I think we got a good overview of states of matter. Now let's move forward. Now let us take up some physical and chemical properties of matter. So what are physical properties? Let me write down. Physical properties and chemical properties. Physical properties are properties which we can observe, right? So basically which we can view. So properties which we can find by observation, which we can view, we can observe, right? Or we can actually touch and feel, right? So those are the physical properties. And what are the chemical properties? So chemical properties are the ones in which substance reacts and changes. In physical properties, there is no change in identity of substance. Right? So that is very important to understand. So in physical property, whatever we say is because of our observation, where nothing is changing as far as the substance is concerned. Right? There could be observations of burning, but the substance reacts and changes. So that will be chemical property. You understand? So the observations where there is no change in the identity of the substance is a physical property. But on the other hand, there could be an observation where substance reacts and changes. That will be a chemical property. You understand my point, right? So for example, if I have a case of boiling water, right? That is a physical. But if I have burning, that becomes chemical change, right? So when we burn something, that material or that substance changes its form, and therefore it is a chemical change, right? So that's what we mean. You understand? So give me some interesting examples here. Let's say when you make a syrup or when you add salt plus water, right? So when you do that part, so this case is a physical change. Salt just gets into water. But on the other hand, if you put soda in water, that becomes a chemical change. Why? Because you see bubbles form. Now these bubbles are reaction, right? Therefore, so what key word here which we have used is substances react. So this is because of a reaction. So that means something has changed in between. Those bubbles are being formed. Correct? But in salt and water, it is a mixture which has kind of a physical property. We say it dissolves. So the physical property here is whether a substance can dissolve. So the property will be dissolving in water. So this is called dissolving in water. When you add salt to water, then the property is to dissolve in water. Here, it is reaction with water. It's a different story altogether. You're getting, so there are a few fine lines here which we need to understand when we are trying to figure out what are physical properties and what are chemical properties. Is that clear to you? So let me give you a good list here. So we have mass. This is physical. Volume. This is physical. Do you understand? Density. How compact the matter is. You can touch and feel, right? Volume. We have already taken. Color. So you can see the color. Then there are some properties like freezing point or boiling point. Now when I say freezing point or boiling point, in that case, state is changing, right? So there is a change in state, but the substance remains same, right? Do you understand? So in this case, freezing and boiling, we have change in state. However, substance remains same, unchanged. So that is important to understand when we talk about freezing and boiling. Is it okay? So that is not a chemical change. It is not a chemical property. On the other hand, the chemical property could be burning. So it's the temperature at which it burns, right? Flash point, for example, right? Could be a chemical property. You get the idea, right? So flammability with change in color gives a new substance. Right? So the flammability will become a chemical property. Right? The other chemical properties which are very popular in your examples are oxidation, like rusting of iron. Right? Now change is brought by yeast, for example. The matter changes, right? So fermentation. So let me add here, fermentation. So in the process of making yogurt or curd or even alcohol from sugar, fermentation changes the substance into a new substance it forms. So that becomes a chemical property. You understand, right? So those are good examples to think about. Now there are some more. Let's say you're making a smoothie, right? Blending. So if you have cutting, shearing, or blending, then you may seem that you have two, let's say you make a blend of strawberries and blueberries, then really there is no chemical change in it. It is those particles getting mixed together, they remain and they have their own characteristic. They don't change. So that is a physical change. So cutting, shearing, tearing, breaking, these are all physical properties. Correct? So when we form or when we beat up something, so drawing, ductibility. So there are other very good properties. Let me write down ductility, shearability, right? Malleability. That means you can beat a metal up and make sheets out of it, right? So those are the kind of properties which are all physical properties in which you will observe that the substance remains as a substance. For example, if you take gold and you beat it up, mold it into a different shape, draw wires out of it, gold remains gold. So it is a physical property which we are talking about. Correct? On the other hand, if you take magnesium and burn it, it gives you a good flame. It becomes a chemical property, flammability, right? So that is how we could actually segregate between physical and chemical properties. So cooking could be here in chemical, right? So you are boiling an egg, the chemical structure of the egg changes. So cooking becomes a chemical property, not a physical, right? So that is how we could actually write down a couple of properties and understand how to categorize them into physical or chemical properties. I hope that helps, right? Okay, so next topic for us now is to consider the characteristics, density, mass, and volume relationship, right? So on this actually we'll have many numerical problems, right? So we'll have word problems here. Well, which will be the next video, right? Very interesting topic and very important from test point of view. The important thing to remember here is coming back to matter, right? So about a matter, we learned that it has two characteristics. First, it has mass. Second, it occupies space. Now, how compactly or you can say how densely, that is where the density comes into picture, right? Right. So we say something is more dense if there's more mass and less volume. Do you see that? So density is basically is the ratio of mass to volume. So for a given volume, if mass is more, then the substance is more dense. That is what we are coming to, right? So when we have the same volume, then the substance which has more mass will be more dense. That is kind of very important to understand. So density is mass per unit volume, right? So normally in the units, we will say grams, centimeter cube. So the density will be grams per centimeter cube. So that will be the unit, right? So density is defined as mass per unit volume. Is density of matter. It is a physical property, right? Mass, volume, density. All three are physical properties. And we'll further explore in our series how to calculate density in different situations, right? We'll just take one example here to end the video. Example is, let's say we have 4 grams of oil, some variety, right? And it occupies a volume which is let's say 4.5 cc, centimeter cube, right? Centimeter cc of volume. Then you need to find what is the density, right? So a simple calculation, we know density is ratio of mass over volume, right? So mass is 4 grams, volume is 4.5 cc. So we'll just divide 4 by 4.5 to get our result, right? So it will be 4 divided by 4.5, which gives us in decimals 0.88, right? Recurring it gave, so we can say it is 0.89 grams per cc. So that becomes the density of this particular oil, right? So a simple calculation will help us find density from known mass and volume, right? Now here's a word of caution. When we're talking about mass, mass is matter contained in a substance, right? There is another term which is similar but that is different, which is weight. Weight is force by which the substance is attracted towards earth for us here, right? So in our case on this, when we say weight here, it means that just weight is a force, mass is the matter contained in a substance. I think that will be enough. So weight is a force and mass is matter contained in a substance, and that is how they're different. So remember, mass and weight are different, right? So you should know that mass is not same as weight. They do have a relationship. They are related. So we can say mass is equal to, we can say mass into force of gravity is weight. We'll learn that later, right? So it is something like this. Okay, so here let's end the video. We understood a lot of things about matter, and we have many other things to explore. So I think we answered all our questions. We know what matter is, what it is not. So energy or a photon is not a matter. So how are photons related? Photons are not matter. We learned about particle theory. We talk about states of matter. So in the states of matter, we say solid, liquid, and gas, right? Well, there are other states also, but which we will not get into. Plasma is another state, right? So it could be plasma, for example. Is it okay? So there are other states of matter also. At this stage, we are not getting into those things. About the characteristics, we saw what are the characteristics. Mainly, all the characteristics are only two kinds. So when we say characteristics of matter, we have either physical or chemical. So any characteristic will be classified into either physical or chemical. Physical means substance remains same, maintains identity. Chemical means it loses its identity. That is the key word, right? So identity decides. If it is lost, it is chemical change. Not lost, it is physical change. Perfect. And then we will look into some ways of relating mass and volume. Density is a good parameter, which is also a physical property, correct? And then we took up an interesting question about something more, you can explore Google to know more about it. Correct? So I hope that makes sense. Go through the links so that you can explore further about matter. Thanks for all your time. Share my videos with your friends. If you like and subscribe to them, that will be great. All the best.